Hey guys, in our last video we discussed numerical differentiation, right? We found an approximation to first order derivative using backward and forward difference, right? So forward difference mean so suppose you want to find an approximation of a derivative at xi, derivative of f at xi, right? Then you use a point in front of xi. So xi plus 1 is a point in front of xi. Then so if you join these two points, then you get secant line. So the slope of the secant line would be your forward difference approximation to this line here, this tangent to the curve at xi, right? So this is forward difference, and if you use a point behind this xi, then we here look at this here, then we can join these 2 points, right? So then we said the slope of the secant line is an approximation to this tangent to this curve at xi. So this is an approximation. So this approximation is called the backward difference approximation to this tangent, right? So here we used only 2 points. Then you can increase the number of points. I think we have discussed that case as well. If you increase here, look at this. Here we use 3 points: x0, x1, x2. So you can find an interpolation polynomial that passes through these 3 points, right? So you can use either Lagrange, Newton's, or you can use what else? Taylor expansion as well, right? So here we used a Lagrange interpolation polynomial. So you can find the Lagrange interpolation polynomial, which is, yep, right, you know that, right? As at the same time you can calculate the error. So when you interpolate using a polynomial, right, using a polynomial, you can compute the error, right? So I think I have discussed 3-point and I have 3-point endpoint formula. That means so this is your curve. Suppose this is your function f, right? And you use this point. So x0 is here. This is your x0. So basically this is the idea. You want to find an approximation to this tangent. So this tangent to the curve at x0, right? Then you use another 2 points in front of this point x0 to find an approximation to this tangent, right? I think we discussed this one in my previous video, right? So if you use 2 points in front of x0, then we say 3. So basically the total number of points here we are using is equal to 3, right? But we use 2 points in front of this x0, right? So this method is called 3-point endpoint formula, right? So suppose this is your f, right? And this is your, say, x naught, right? And now we choose 2 points in this way. One is from a point behind x naught. This is x, say x minus 1. Say this is your x1. So to approximate the tangent to the curve at x naught, so we pick 2 points so that one point is located behind x naught and the other point is located in front of x naught, right? So here you can say x naught is the midpoint or center of these 3 points, right? So this method is called 3-point midpoint or central difference formula, 3-point central difference formula, or you can say a 3-point midpoint for a midpoint formula, right? So as we did previously, we can find the Lagrange interpolation that passes through these 3 points, right? We can find that formula, right? For our convenience, you can think this gap is h, same a gap. For our convenience, in general, you don't need to put h here, right? But in the exam, you have limited time. Your time is limited, so you don't have much time to compute the general one, right? We consider these gaps are the same, right? These gaps are equal to h, right? All right, so that means these xi's are equally spaced. These xi's are equally spaced, right? For our convenience, right? For that case, so this is the formula, right? You can find the Lagrange interpolation that passes through these 3 points, right? And substitute these, so you get something like this. I think we have done that. Here's something like this. Here we use 3 points. This time xi is the midpoint and the one. Yep. Then you can find the Lagrange polynomial, interpolation polynomial that passes through this one here, that passes through these 3 points, right? So you can compute, right? So I recommend you to sit down with a piece of paper and do these calculations on your own, right? So it is very important, right? So you are asked to derive these kind of things in your exams, right? So that's why make sure you be familiar these derivation of these formulas using any number of points. Here we use 3 points, so we want to find an approximation. So this is the approximation value, right? This is the approximation to this, right? To this. This is 2 point. 2 point. Yeah, this one is the central difference. Yeah, this is. So here we use 3 points. Yeah, do this on your own, right? First you have to find the Lagrange interpolation polynomial that passes through these 3 points, right? And with the error, always derive the Lagrange polynomial with the error, right? So something like this here. So this is the error term, this is the error term, and this is your polynomial. Now you can differentiate. If you want to find the derivative of f, then you can differentiate this polynomial, right? You get something like this here, right? Then you can substitute the point. So this is your approximation, right? Here, not here. Yep, this is your approximation, right? This is your approximation, and this one is the error term, right? So approximation to this derivative, right? Then if you want to find an approximation to this derivative f prime evaluated at x naught, you have to substitute x into the formula, right? Then you get the approximation value, right? Approximation thing to this, right? So I think you can do this. I think you can handle this on your own. So if you, yeah, so this is the approximate 3 point. So there are two ways to find an approximation. This is the forward. This is called 3 point endpoint formula. That means you used another extra 2 points in front of x naught in order to find an approximation to this derivative at x naught, right? So here the case is different, right? Your x naught in the middle of x1 and x minus 1 and x1, right? Then first find the Lagrange polynomial, interpolation polynomial that passes through these 3 points, then substitute this point into there. That's all, right? With the error, right? Then simplify. Then you can separate the error term as well as the approximation to this. That's all, right? So this is called a 3 point midpoint formula. Right, I will ask our teachers Anuttara and Chamila to work on these problems, right, for you, right. So the similar way we can talk about 5 point formula. That means you use another extra 4 points. So this is midpoint, this is endpoint. Let's discuss this. Yeah. So this is your function f. So you want to get an approximation to this tangent to the curve at x naught, right? Now we use another 4 points here, and we assume, for our convenience, we assume this gap is, all gaps are equal to the same number h, right? H is the gap, right? This is your x1, x2, x3, x4, right? So these are the corresponding bytes, right? Then you can find the interpolation polynomial that passes through these 5 points, right? Then differentiate that. So find the interpolation polynomial with the error, right? Error term, and then differentiate, then substitute the point you want to find the derivative, then substitute x naught into that, then you get this thing, this huge thing, right? So in the I think these type of questions won't come in your exams, won't come in your exams, because this is so you have to do a lot of calculations. It takes time to compute these things. I think this is fair enough to, yep, this one is all right. So this one will come up in your exam, I think. Yep, only 3 points, but yep. So for 5 points, it is, yep, difficult to compute, difficult to do these algebraic manipulation, right? During the limited time period, right? So right. So this one, then substitute x naught into that, then you get this. So this is your approximation. This one is your approximation to this, and this is the error term. You can say, you can find here. So the accuracy, the order of the error is 4, right? So this one is much better than the previous one. The order of error is 2, here 4. Much, if you make this h small enough, then you can reduce the error. So here you use lot of points, you use 5 points to find an approximation to this, right? All right, I hope you understand. So this is the 5-point endpoint formula. That means you are finding an approximation to this tangent at x naught using another extra 4 points in front of x naught. So the total number of points is equal to 5, right? So let's look at this case, right? 5-point midpoint formula, right? This is your x naught. Now we pick 2 points in front. Say this is x1, x2, and this is x minus 1 and x minus 2. And for our convenience, let's assume these gaps are equal, right? H, the gap between any two consecutive points, is equal to h, right? So find the Lagrange polynomial that passes through these 5 points, right, with the error, right? Find that, then substitute x naught into that, right? Then you can come up with this formula. So this is your approximation. This bit is your approximation. Where's that? This one is a little bit wrong. Let me, yep. All right, look at this one here. So this is your approximation to this. So this is so we use 5 points, right? 1 2 3 4 5. Yep, we use 5 points. So this is an approximation to that, right? So that one, this one is an approximation to this. I think this is a little bit wrong. I think you can see this minus plus and minus 8 plus, yep, and the error term would be order of 4. I think, yep, this should be plus, I think, right? Multiplied, right? Plus. So this is your error term and this is your approximation to this. So here x naught would be the midpoint of these, the set of points, right? X point. That's why we call 5-point midpoint formula, right? Right. So This is the thing, and the order of error is 4. So this one is much better than the previous midpoint. The order of error is 2. So if you make this error the size of h small enough, you can minimize the error. So this is the approximation to this, and this is the error term. I hope you understand this one more clearly. In my next video I will talk about how to find an approximation to second order derivative. That is pretty simple, right? That is pretty simple. So in my next video I will talk about that. I hope you understood the first order case. So earlier we used 2 points. You use, yep, this is 2-point approximation. 1 2, this is x0, this is x1. Yep, this is x0, x1. So this gap is h, that's why you get x1 is equal to x0 plus h. So earlier one we use 2 points, and now we increase another point. So this is, so using 3 points we talked about, we talked about midpoint approximation and endpoint approximation. So this is the endpoint approximation with the error. So this is the midpoint approximation with the error. You can see that the order of error is 2, right? This one is much better than the approximation using 2 points. So look at the error. So where's that error? Yep, error is order 1, right? But yep, so when you use 3 points, the order of error is 2. Alright, if you make the size of h small, you can minimize the error. Now you can increase the number of points, then you can approximate. You can find an approximation to this using these 5 points, right? Hope you, if you want, you can increase number of points. You can find 5-point midpoint formula or 5-point endpoint formula. Anything you can find, right? Maybe there. So this is the error term, right? Alright, I hope you understand this one.